Hey guys, welcome to a new video. In this video, I'm going to explain a concept which has confused students for a long time: distance and displacement. So you can see a car which has been parked near a tree and it is not moving at all. So we can say that the car is at rest. So an object is said to be at rest if it does not change its position with respect to time. So how do you define an object which is in motion? An object is said to be in motion if it changes its position with respect to time. So the position always changes with time. Here, how do we define a position? How do you describe a position of an object? You can either define it like the car is parked near the tree, or the car is parked at the left side of the road with respect to the driver. But does that description holds up really well? Not really, because you can see that if the car takes a new position as shown here, the same description, that is the car is near a tree or the car is at the left side of the road in the perspective of the driver, both that definition holds up for this position also. So our description of the position of the car is actually not very unique. It's very vague. So we need an alternative way to define the position of the car, or generally speaking, we need to come up with a better way to describe the position of an object. So for that, we are going to have a fixed frame of reference. So how do we create a fixed frame of reference? So in this context, basically, since all these are in two dimensions, we will define two axes, x and y axis. Basically, they are two straight lines which are perpendicular to one another and they are intersecting at a point called origin. Each of these axes are divided into equal units. So with respect to this axis, I am going to describe the position of the car. Let's see how can we do that. By observing this picture, we can say that the car is 8 meters away from the origin in x direction and 6 meters away from the origin in y direction. So using these two descriptions, we can accurately describe the position of the car, and combining these two numbers, we can write it as a coordinate. So a coordinate is something, basically we write these numbers 8 and 6 inside a bracket separated by a comma. So if the position is at rest, the coordinate of the position of the car does not changes, meaning the number 8, 6 will remain the same for all times if the object is in rest. So let's see another example, a more simpler example. So we have drawn the axis x and y, and this is a fixed frame. The axis does not move with respect to time. The axis itself is in rest. So we can have a fixed frame of reference and assume that there is an object which is indicated by a blue circle here for simplicity, and the current coordinates of this, or the current position of this object, is 5, 4. This indicates that the object is currently 5 meters away from the origin in the right direction along x-axis and 4 meters away from the origin in y-axis, away from the origin above y-axis, above the origin. Okay. Now, if this object is subjected to a motion, the position will change definitely. So the position changes continuously and it reaches a point where it remains at rest after some time, and the new coordinate can be defined as -2, 2. Basically, this means that the new position of the object is 2 meters away from the origin in backward direction and 2 meters away from the origin in upward direction in y-axis. So we can see that the position has changed when the object was subjected to a motion. We will define the distance and displacement in the context of a motion in a straight line. So here is an example of a motion in a straight line. Consider an object which is indicated by a brown circle and it is subjected to a motion starting from O, then reaching the position R, then coming back to the position U, and finally arriving at a position P. So even though it had some kind of a zigzag motion, it still followed a straight line motion. So you can ask that what is the significance of a straight line motion? Is it applicable anywhere in our practical life? Actually, yes. We can approximate some of the motion we see in our day-to-day life as a straight line motion. One of such example is a car going through a straight road, and another example is a motion of a train. So the rail tracks are usually straight, although there are some curves here and there, but it can be approximated as a straight line motion. So studying a straight line motion is actually okay and is helpful for several practical purposes. So let's start defining distance. So what do you mean by distance? Both distance and displacement are actually a measure of the length, but the definition of both these terms are entirely different. So that's why we are first starting with the definition of distance. Distance is defined as the path length traversed by the object. It is defined as the total path length traversed by the object. Let's see with the help of an example. Imagine there is an object presently at origin. We are only considering one axis because this is a straight line motion. Only one axis is considered here and its origin is at O. And several position is indicated by different alphabets P, Q, R, S, T, U. And the corresponding coordinates are also indicated here. Since it is a one-dimensional motion, the coordinates is only having one number. Unlike the previous example where we had two coordinates, both in the x direction and the y direction. Here, since we are considering only a one-dimensional motion, we need only a single number. So the motion starts from O, then reaches R, and finally it reaches P. Let's see that motion. It starts from O and reaches R, then comes back to a position P. So what is the total length traversed by the object? Total length traversed by the object is sum of lengths OR plus RP. So distance is equal to OR plus RP, which will be equal to 12 plus 8 equals 20 meters. So the total distance traveled by this object is 20 meters. So what about displacement? So displacement is defined as the change in position. It is defined as the change in position. So basically it means that it does not consider which path it's traveled, but only consider the initial position and the final position. Let's see with the help of this example. Here also the object is traveling through a similar path O, R and P. And if we calculate the displacement, we will see that this is simply equal to displacement is equal to final position minus initial position, which is the final position is the position P indicated by the coordinate 4, whereas the initial position is the position O, origin, which is indicated by the number 0. So therefore the displacement can be obtained as the subtracting final position from initial position, that is 4 minus 0, which is equal to 4 meters. So you can clearly see that both distance and displacement are different quantities. So let's formulate an expression for displacement. if x1 is the initial position at time t1 and x2 is the final position at time t2, we can write an expression for displacement as delta x is equal to final position minus initial position equals x2 minus x1. Now let's see the difference between distance and displacement. The distance is defined as the total path length traversed by the object, whereas the displacement is defined as the change in position. Distance does not include the direction of the object, meaning it only gives you the total path length, whereas displacement indicates the direction. Displacement indicates the direction from the perspective of the initial position, or is the final position in the forward or backward direction with respect to the initial position. That's what it indicates. Distance is always a positive quantity, whereas displacement can be positive or negative depending on the direction. Means positive means it is in the forward direction with respect to the initial position, and negative means it is in the backward direction with respect to the initial position. And finally, if the object is in motion, distance cannot be zero, whereas in the case of displacement it can be zero even if the object had a motion, because if the initial position and final position both are same, then the displacement will become zero. Let's see one more example to illustrate all these differences. Let's see an object which is initially placed at a position P other than the origin. In the previous cases, the object was starting from origin, but here we are placing the initial position of the object as the position P, which is indicated by the coordinate 4, and it undergoes a motion from P to Q and then to S. So the initial position is P and the final position is S. Let's see what is the distance and displacement of this motion. The path is PQS, therefore the total path length, which is the distance, is equal to PQ plus QS, which is equal to 5 plus 11 and which is equal to 16 meters. So 16 meters is the total path length traversed by the object. Let's see what is the displacement. Displacement is equal to final position minus initial position. The final position is the position S, which is indicated by the coordinate -2, and the initial position is the point P, which is indicated by 4. Therefore, final position minus initial position will give you -2 minus 4, which is equal to -6. So here the -6 indicates that the final position of the object is 6 meters behind the initial position, or the final position is 6 meters in the backward direction with respect to the initial position P. So therefore we can clearly see that the distance is positive and displacement is negative. Distance does not indicate the direction, but it gives you the total path length traversed. Displacement gives you the direction of the final position with respect to the initial position, but it does not indicate the total path length traveled or how much fuel did you burn. These values cannot be calculated using displacement, but distance will give you that. And in the next video we will discuss another confusing concept which is haunting the students for a long time, that is velocity and speed. If you find the video useful, please hit the like button and subscribe the channel for more videos. Bye.